Hi everyone and welcome to Techweek TV, brought to you by Callaghan Innovation. Super excited to have you joining us this afternoon. This session we are going to be learning how the Kiwi tech industry is showing the world how to decrease the amount of waste that goes to landfill. It's a very big problem, and for some context I wanted to give you some numbers. So there is an estimated 80,000 tonnes of e-waste and hundreds of thousands of tonnes of food waste going to landfill in New Zealand every year. The issues here not only include environmental impacts, toxicity and land space. Some of the materials sent to landfill, particularly for e-waste, are becoming increasingly scarce. Joining us for this session today, Michael Garvey, founder at Foodprint, Ian Hoyce, founder at Revolution Fibres, and James O'Byrne, founder at Avatana. Thank you so much for being here. How are you?
Good.
Good, thanks.
So to give you a bit of an overview of this topic and what these amazing founders are doing with their businesses, we are going to go to some presentations. Over to you, Michael.
Yeah, thank you. Cool, so I'm going to start off today by talking about food waste and sort of give a bit of an overview of why it's a problem. And then I'm going to introduce you guys to Foodprint and what we're doing to rescue food before it becomes wasted. So when a lot of people think about food being wasted, they don't really see it as a problem, but actually it's got huge issues both socially and environmentally. So on the social side of things, like governments and NGOs around the world are asking, like, are we actually going to be able to feed the population when we get to 2050, when we reach 10 billion people? But the reality is, at the moment, we're already producing enough food to feed that many people, and we're currently only 7.5 billion. To make this sort of worse, what's actually happening is that each day 1 billion people go to bed hungry. So it sort of shows that we're doing this massive overproduction in some areas and then creating waste in others. And in those areas where the people are sort of going to bed hungry, that's going to continue to get worse as the population grows, because those are the areas that are already struggling to keep up with the demands of their population. And in those areas where we're overproducing, obviously this is generating a huge amount of waste. We produce so much waste these days that it is now widely accepted that we are producing, oh, my clicker's not going, that we are wasting around a third of the food that is produced for human consumption. There we go. And obviously this waste then has huge environmental impacts. So we really are at a crisis point with climate change, and we need to stop just talking about it and actually take urgent action to make sure that we limit global warming to 1.5 degrees above pre-industrial temperatures. And like all industry, the food industry and food waste specifically has huge environmental impacts. And what happens is that when food is wasted, it's sent mostly to landfill, where it emits the greenhouse gas methane. Now, methane has around 30 times the heat trapping capabilities of carbon dioxide. So it is a really massive issue, and it's one that we can totally avoid by reducing the amount of waste that we are producing. So I wanted to sort of have a bit of a think today about like what's actually what's actually being wasted when we waste food, because it sort of goes well beyond just that item that you're throwing in the bin. So what I want everyone to do is have a think about a loaf of bread. Now, oh, I missed the slide there. There we go. Now, I've chosen bread today because bread is the most wasted food item in the world, and in New Zealand we waste 29 million loaves every year. Yeah, it's massive. Yeah, so it goes well beyond that. And the reason that we waste so much is that it's relatively cheap and it's accessible, but if it's not stored correctly, it only lasts us a few days. So when you're thinking about that bread, it started off its life as a crop of wheat. There we go. And that wheat needed soil and water to grow. So we're wasting a third of that. Someone then owned the land that crop was growing on, and they've hired people and powered machinery to work that land. So we've wasted all of that. The wheat has then been taken to most likely, or at least one, if not more, processing plants where it's been turned first into flour and then baked into bread. So we've wasted that transport and all of the process that's gone into that. It's then been taken most likely to a supermarket where someone spent their time stacking it on the shelves. So we've wasted that time and space as well. Bread is usually put into single-use plastic, which has also been wasted because it hasn't actually fulfilled its purpose of keeping that bread fresh and ready for consumption. So as you can see, there's sort of a lot of different steps and a lot of people have been involved with that. And the final thing to say here is that we've wasted a whole lot of money. We're literally just throwing our money in the bin when we're wasting food. So hopefully that kind of gives a bit of an overview of the bigger picture. I wanted to bring us to New Zealand now as well. So in New Zealand we waste over 300,000 tonnes of food each year. Just over half of this is actually wasted from our homes. So we're filling our fridges with food that we're not eating. We're terrible at eating our leftovers, and we're really good at throwing things out well before they've actually started to grow things. Then the other half is sort of split between the commercial sector. So this is the people who are producing and growing the food. Food is getting lost in transport or rejected for cosmetic reasons. And is just sort of being overproduced. And then the remaining sector, which is around 50,000 tonnes, is from the retail sector. So that's the supermarkets, cafes, and restaurants, the people that sell, directly to the public. And it's this last sector that we are starting to tackle with Foodprint. So, Foodprint is a mobile app that connects eateries with surplus food to our users who then purchase and consume the food, rescuing it before it becomes wasted. My journey with Foodprint started when I was living in London. I was working at a food tech startup, and it was there that I really saw the place that technology plays in how we source, purchase and consume our food. And by sort of adding a sustainable lens to this, my vision for Foodprint grew. We're really lucky that in 2019 we literally walk around with this amazing technology in our pockets that can help us live our best lives. And I wanted to kind of harness that and create a community of people who are really committed and showing their commitment to this issue of food waste. And I believe that Foodprint provides a really practical, easy to use solution for everyone to reduce their footprint. I'm going to play a really quick video because I think that that's the best way to explain how it all works. So here we go. So hopefully that gives you a little bit of an overview of how the app actually works. I've just got a couple of highlights here. So once you download the app, you're able to search for food that's available to rescue from the eateries. You can apply filters based on your location, your dietary preferences and price. And then you purchase within the app. It's just a couple of really quick, easy clicks to purchase. And once you've purchased, your order shows you how long you've got to collect the food until the eatery closes there. The app also shows for both the users and the eateries that we've partnered with how much food they've saved, how much money they've saved, and also how much carbon they've saved. So keeping the environmental issue right at its heart. In terms of the food itself, it is still perfectly edible food. There is absolutely nothing wrong with it. It might be surplus because an eatery has had a slow day, or they've cut a piece of cake or slice that's got a little bit broken, so it might not look as good cosmetically, but it's still going to taste exactly the same. Or in the case of grocery, it might be sort of nearing the end of its, coming to its best before or use by date, but it's just the same as when you go into the supermarket and you see the little reduced to clear stickers there. For the eateries who partner with us, it means that they're able to retain some value in that food and also limit, obviously, how much they're sending to landfill or to compost. So some of those eateries who we've already partnered with include Right Deli, Mexico, Little Bird Organics, Bird and Boy, Williams Eatery, and Bread and Butter Bakery, but there's plenty more to come. So hopefully some of you guys are looking forward to joining us. We haven't quite launched yet, but we're only a couple of weeks away. The best thing to do is just to follow us on our social pages for now, and you'll be the first to hear of the updates. And look, the last thing I just want to finish on is, like, if you have an idea, it doesn't matter how big or crazy it is, just start talking about it and be really proud of it. And if anyone wants to hear more about my personal journey, then my LinkedIn's there as well. So, cool.
Awesome. Cool. Thank you so much, Michael. Amazing mission that you're doing. So now to get into the hard stuff, I have a few questions for you. We used to run events at the Kiwi Landing Pad, and sometimes we would have leftover food. Yeah. And our biggest problem was, where do we send it? And it was perfectly good food, catered. And often city missions and people who are feeding people won't take food. And in our case, we were lucky that we actually knew the person, so they did. But it is a problem in terms of food safety and hygiene. So do you have any thoughts on why that problem exists, and also how we can get around it? Yeah, so something like that, obviously the issue is over catering, or people maybe not being aware that it's a catered event and that they can, they need to eat things. That's a really tricky one for us in terms of actually being able to sell food that's kind of been left out. That's, again, for that food safety, we can't really do too much about that. So I think the biggest thing is for people just to sort of don't be afraid to under-cater something. I think a lot of the time people aren't expecting to, if you go to an event, you're not really expecting to be fed. It's often quite a bonus. So just really thinking about, like, how much we're actually ordering, and is it all going to get eaten? The other question I have, and so from the start of your presentation, when you really broke down what goes into bread, it's almost like when people work out their true hourly wage, and when they add in commuting and the emotional cost of working all the time. It was apparent to me that maybe people don't actually know the true cost to produce. So how do people learn more about that? I think, I think people don't understand the true cost to produce, and they also don't understand the afterlife. We're so consumer driven, and everything is just sort of like, we only think about the time that we are with something. So one of the really big things is understanding where your food is coming from, and knowing if it's from New Zealand or if it's come offshore. And I think there's definitely a big move in that direction at the moment. People do actually give a damn where their food has come from. So I think the consumers just need to sort of keep driving forward with that pressure. And for Foodprint, you do go in and collect the food. So for me, that is sort of the first step in encouraging people to go back to that eating locally. Awesome. And the last question I have for you is best before dates. Maybe all of you could jump on this, but are they really like what is a best before date, and could we push them out by a day? So I mean, often they definitely can be pushed out. The biggest thing that people need to do is use your senses. Like, we've got these senses, and we don't just have them for fun. They're there to help us survive. So, if you can see something as growing green stuff on it, then maybe don't eat it. But, if you've got like a tub of yogurt or something that's been sitting in the fridge for a week, and it says it's past before its best before date, but nothing's growing and it still smells fine, taste a tiny bit of it. You're not going to get sick off like a teeny little speck or something. So be really aware of that stuff. Like, cut the little bit of mold off your cheese. It's still fine. Awesome. Okay, thank you so much. Right, we're going to James next for your presentation.
Hey, so thank you. It's really cool to be here, especially in the Waste to Value session with Techweek. What we do, our business at Avatana, is absolutely about waste to value. It's central to what we do. Essentially, our business is taking big volumes of heavy industrial waste and refining that into the raw materials that go into stuff that all of us use every day. And before I get into too much detail about what we do, I think I'd like to share with you a really interesting fact I came across a couple of weeks ago. So it turns out that in September 2018, according to the Brookings Institution, half of the world's population, so 3.8 billion people at that time, were middle class or wealthier. And it's a funny kind of fact to bring up with respect to waste, but I'll explain why. When people are no longer poor and looking just at their needs, looking at what they're going to eat, where are they going to get clean water, where are they going to find shelter, then inevitably it's just human nature. People start to think about their quality of life. And if you take a family that's recently moved into the middle class in developing worlds, Southeast Asia, for instance, then people are going to start thinking about things like, well, we've got a house and we're doing okay. Should we get a motorbike? Should we get a small car? Maybe we should paint the house. People start to kind of raise their eyes and think about how they can improve their lives and maybe get a smartphone, a television, those kind of things. And that's great because people's lives are getting better, and that's something that should definitely continue. But nothing in this world, as we know, is free. And so all of those things that people want and things that people need have to come from somewhere. And when you track it back through the value chain, almost everything comes from a big hole in the ground somewhere. And on the journey from that big mining hole somewhere to you, there's been numerous processing steps, and often during those processing steps, there's stuff thrown away as well. So this is really important because, as we heard a little bit earlier, right, we're on a planet at the moment of about 7.5 billion people, and that's going to keep growing, and the UN thinks that it's probably going to go to 9-10 billion people. How are we going to provide for not just the needs, but the wants of the next 2 or 3 billion people without completely trashing the planet? Because I think it's pretty common knowledge now that things are in relatively bad shape already. And so that's where what we do at Avatana and other companies in the waste to value space comes in. Our business is around taking big volume industrial waste and saying, well, actually, no, we don't believe that's a waste. That's a resource, it's just that nobody's figured out how to use it yet. So what we can see here is a mountain, an artificial mountain that sits out the back of a steel mill, in this case, in a closed steel mill in South Africa. So what you're looking at is a small piece of something that is actually about 54 rugby fields in area, stacked 65 metres high. It has its own roading network and railway line. So that gives you some idea. And you can actually see it from space if you jump on Google Maps. This is not unique. There are thousands of these types of industrial waste dumps scattered around the world. Some of them look like giant red swimming pools. Some of them big piles of rocks like this. Other ones, someone has taken a valley and is just slowly filling it up. So this is something that, although it's usually out of sight, out of mind to those who live in cities, is actually out there and going on all day, every day. So what we're focused on right now at Avatana, our current patented process, is to take the slag, which is like essentially burnt rocks that comes out the back of a steel mill, and to break that down into all of its constituent parts, and then to sort those into different raw materials that are used for manufacturing. So the real moneymaker for us in the slag that we're focused on is titanium, titanium pigment. And you can think of titanium pigment, it's just a very plain white powder, as sunscreen for paint, which sounds really weird, but what that means is that's what imparts on paint both its opacity, so it covers up whatever it's on top of, and also helps to protect whatever that surface is from the sun so that it doesn't get weathered and break down quickly. So when you slap this up on a wall, wood or whatever, then that's going to last 10 years. It's not going to start to fall to bits in a couple of years' time when it's exposed to the elements. We also make aluminium sulfate. So aluminium sulfate is essential for making clean drinking water, but also if you've got wastewater, then it's something that you're going to need to take out the sediment, to flocculate out and bring together all of the solid bits so that that water becomes something you can either retreat or discharge. We make magnesium sulfate, which is used as a fertilizer, particularly for things like potatoes and tomatoes. And again, growing population and people wanting more quality food, that's essential. And then gypsum, which goes into cement and concrete and construction materials. So things to house people, and as we know, with urbanisation continuing, there's not going to be a shortage of need for any of those things anytime soon. But most importantly, on top of the things that we do make, is what we don't make, and that's nothing else. So everything that's in the slag is actually processed into products, and we don't have a nasty smaller waste stream that comes out the back end of the plant that then needs to be dealt with some other way. So our value proposition is essentially to be able to make these essential manufacturing more materials more cheaply than they're currently made with existing processes, and using a waste that's currently not something that's commoditized. So if you look at the mining industry nowadays, all of the raw materials, be they iron ore or bauxite or whatever, are commoditized. You can trade them, companies buy and sell all the time. When you partner up with an industrial waste producer, you're not tied to that commodity cycle. So that means you've got a much more reliable cost position. The process we've developed also on the cost of building a factory basis is in line with existing ways of making titanium pigment, and also makes these other products. And when you've got a number of different products, you're not entirely locked into one market. So volatility in one market can be hedged by having other products you're also selling. Environmentally, when you're starting with a waste and you're turning that into products again, then your CO2 footprint is going to be considerably smaller, because you've actually cut out a substantial part of the supply chain that was used to make that product, and you're starting with something that industry wasn't going to use anyway. And then by not mining that product on purpose, you don't have the economic and the environmental impacts of doing that as well. So it all adds up quite nicely in terms of the overall value to the value chain. What we're seeing around the world, not just in the pigment industry, but actually across the whole industrial raw materials space, whether you're in metals, mineral processing, chemicals, is government regulation is stepping up. And it used to be that there was somewhat of an imbalance. In some parts of the world you could get away with things, in other parts, for instance in the EU, there were tougher regulations, but it's becoming much more flat now. So in China we're seeing a lot more plants being shut down because they're not complying with increased regulation. We're seeing this happening now in Africa, in Southeast Asia. So industry is actively looking for ways to be cleaner, and it's being pushed to do that by government. And this is also coming through from the other side with consumers, because consumers are thinking about what's going into the products they buy, and they're saying, well, actually, I want to buy a product that I don't feel is going to be causing a whole lot of environmental harm that I don't know about. So they're asking the companies that sell them these products, what does your supply chain look like? Are you actually sourcing from responsible producers? In terms of our technology, we've been on this road for 5 years now. It's been a fun ride so far, and we've started at very small scale in the laboratory, so we're talking about like tens of grams in a beaker. We've been through 3 iterations of pilot plant now. So a pilot plant is something that looks like a little bit like a mad scientist setup. If you can imagine big glass vessels all bubbling away, but all hooked up together with pumps and pipes and sensors and that kind of thing. And we're now into the pre-commercial or demonstration plant phase. So this is now something that looks like a mini factory using real industrial equipment. And the next step after this is going on to full commercial build, and then you're talking about a fully integrated factory that either sits next to a steel mill or is located somewhere else closer to markets and can take in hundreds of thousands of tons of slag a year and turn that into products. So this is a shot here of our demonstration plant in South Auckland. And as you can see, it's mounted on skids, and then we have in there equipment that's been supplied by industrial vendors who already supply equipment into the chemical industry for the types of applications that we're practicing. And we're using this not only to make product samples for potential customers for our technology and companies who make the products that these raw materials go into, but also to give us the input design data to go and build those big full-scale industrial plants. So as we're stepping through our timeline, we're now into the second stage of pre-commercial development, and we expect to be starting to construct our first plant in the course of 2020, and hopefully to be shipping products to the world in 2022. We started this journey here in New Zealand looking at the slag that comes out of BlueScope Steel's Glenbrook steel mill, and as we moved along the path we realised actually that this is definitely not just a New Zealand thing. We have identified multiple plants, dozens in fact, around the world that make titanium-rich slag that's applicable to what we do. So Russia has a steel mill that makes 1 million tonnes a year. China has multiple steel mills and literally hundreds of millions of tonnes of stockpile. There's that big one we saw in South Africa, and more recently we've discovered there are also opportunities in the Americas, both in metallurgical slags, not from steel, some other stuff, and in unconventional mineral deposits. And on this journey we've been very lucky to have been recognised by a few parties who know what they're talking about, And the ones that really stand out for us are the Institute of Chemical Engineers, which is a UK-based international organisation for chemical engineering, and also ICIS magazine, which is one of the biggest chemicals publications in the world. And last year we were really stoked to be nominated in the APAC 25 list by the Clean Tech Group. So as we see it, we're providing a piece of the puzzle in terms of a global solution to a very, very big problem, big, complex, gnarly problem. And it's really all about where you stand and how you look at the problem. We can say, yep, there's a problem with waste, or we can say, actually, there's a whole pile of resources out there that's just that no one's figured out how to use them yet. And so we think we've got the team to deliver on that, but I think that also there's a fantastic opportunity for others out there, particularly if you're in the science engineering fields, to have a look at these interesting problematic wastes and say, well, what could these be, rather than how do we just kind of hide this away. So yeah, that's what we do.
Amazing. I hope you're feeling super inspired right now. I certainly am. A few questions for you.
Please.
The raw materials, just want to clear this up. So are you making your own paint to sell?
No. If you think about the consumer being, I guess, the end of the value chain,
Yeah.
the consumer buys paint from somebody. So here in New Zealand, you buy your paint from Resine.
Yeah.
The paint company buys their pigment from a pigment company.
Right.
And globally there are a few dozen pigment companies, but there are about half a dozen really, really big ones.
Right.
And for us, that's really where our customer is those
Gotcha.
pigment companies who would use our technology to make the same stuff that they currently make, but to do it much more cleanly.
Gotcha. Okay. That makes more sense. Do you think would it ever be worth, like, actually going, you're obviously cleaning and reappropriating resources, but do you think there would ever be a use case where it would be commercially rewarding to actually start selling these products if you know what they're going to be? You probably can't talk about that.
I think there's different strategies you can employ. For us, we could see possibly some value in co-branding with people who are downstream. So if you think about some of the big paint companies, they've set some really challenging targets for themselves for 2030 in terms of sustainability. And so for them, the ability to say, yeah, we're using raw materials that we know come from a much better place than what we were using before. I think there are some opportunities potentially to do some marketing partnerships like that. But for us, the longer term vision isn't really to go deep on the supply chain, it's actually to go out.
Yep.
So what we're interested in is to go beyond slag and beyond the metals industry, and to look at other big, heavy industries that at the moment are making these giant waste piles, and to say, how can we plug these into other supply chains and turn them into kind of a force for good and something that can actually be put to work.
So really it becomes a bit of a circular economy. That's
Very
what you're
much
aiming
so,
for.
yeah.
Great. Biggest challenge for you right now?
Growth. We're at 35 odd people now, and we have found as we've gone along that recruiting the kind of technical specialists we need does get harder because New Zealand is a relatively limited talent pool, and to be honest, we work in some quite niche areas of science and engineering. So there's that, and just managing a company, you know, the step from 20 to 35 has been a really big step change in terms of what it's like to actually manage that kind of business. So yeah, we all have to keep kind of stretching ourselves and growing.
The fun stuff. How does the slag get to you?
At the moment, we're able to, for New Zealand, we pick it up from a distributor. It's currently used as aggregate, so you can go and put it on your driveway if you want. It's used for roading, those kind of things. So that's pretty straightforward. If you look at overseas, we've been able to secure samples from China, from Russia, from South Africa, and they need to be shipped in. But the long-term vision is that you would locate plants either close to where the slag is, and so it can be put on the rail, or even maybe right next door to the steel mill, or alternatively that you move the slag to where the markets are, and you have a plant, say somewhere in Southeast Asia, for instance, where you're really close to fast-growing markets for those products, and the slag is just brought in as the raw material, but it's just being entirely turned into stuff that gets sold in the region.
For those people just who are a bit curious, if you have like a steel mill, what's the how long does a steel mill typically, are they in production, getting the steel out? I don't know anything about resources.
Sure. So industrial assets, you know, be it a steel mill or a chemical plant, their lifespan gosh, some of them live longer than people. They can exist on the same site for a century in some cases. It's what they call grandfather's axe. First you replace one bit, then you replace the other bit. And so eventually it may not be the same steel mill, it may not be the same chemical plant, but you still have a working asset that continues on that site. And it's not in the interests of a lot of these producers to close because there are huge remediation costs to clean up those sites. And so if there's technology available that allows them to upgrade and to do what they're doing in a cleaner way, then they can actually keep sustaining their business, keep those people employed, and not have to pay those closure costs.
Awesome. Okay, thank you so much. Ian, we are going to go to your presentation now.
Sure.
Do you have the clicker?
If you had to guess what this is, you probably wouldn't say it's a nanofibre made from fish skins. But that's exactly what it is. A nanofibre tissue that dissolves completely, delivering collagen deep inside the skin. And testing has shown it can reduce facial wrinkles by more than 30%. We'll get to that, but first we need to start here, with fresh fish caught by Sanford, New Zealand's biggest and oldest seafood company.
Well, at Sanford we're trying to be the best seafood company that we can be. The best seafood company in the world is our ultimate goal, and this is part of a drive to utilise as much of the raw materials as we have available to us, part of a wider extracts program.
Yeah, science is a big part of what we're trying to do at Sanford now, particularly trying to utilise our fish stocks better and in a more sustainable manner. So that's taking a lot of our waste and byproducts and putting them to better use.
The process of putting them to better use starts here. This is Plant and Food in Nelson, where scientists have developed the technology to extract the collagen from the fish skins.
Collagen is a structural protein. 30% of our dry body weight is collagen. So our bones, our tendons, it's in the liquid in your eye, it's in the discs in your back, it's the extracellular matrix that all the cells are in. So it's a very important protein in the body.
The collagen then heads to Revolution Fibres, where the next bit of magic happens.
So we create nanofibres by putting a polymer, in this case collagen, into a high voltage field, and the fibre collects from one side to the other.
That nanofibre is then spun into the face masks you see here. Revolution Fibres thinks these will be a revolution in skincare.
Nanofibres have a unique structure in that they are very, very thin. They're able to hold in them a number of other substances, natural extracts that can be included in the formulation. It's the first application method of its type like this.
We've been working closely with Otago University School of Medicine to track how our fibres dissolve and penetrate the skin. And what we're seeing is very deep, long-lasting penetration of the active ingredients as well as the collagen.
The technology has the potential to do more than just fight wrinkles. It should soon have medical applications too.
Our aim by 2020 is to have a medical product on the market. We believe it's got a lot of potential in drug delivery, anything from burns to treating acne, to treating skin lesions and diabetic ulcers. So it's got a huge amount of potential.
Revolution Fibres face masks are about to launch into Asia. From there, its home market in New Zealand will follow. Sanford will be partnering with Revolution Fibres all the way.
Well, I'd like to think of Sanford as our knight in shining armour, if you like. They really came to us when we were in quite a bind. We needed a big scale up. There wasn't the market there, so we needed a company that could share the vision of where this technology could go. They took the R&D and they turned it into a manufacturing process very quickly, very professionally, and they've just been great partners. Great. Well, I was cheating, so using a video. So that's half the presentation time gone. So our company, Revolution Fibres, is one of the global leaders in nanofibre production. So we create innovative textiles from a wide range of polymer materials, plastics, and we develop superior products using our textiles. We work in air filtration, skincare, medical with the active layer product that you just saw. We're working in the carbon fibre industry. Nanofibre is the thinnest and most lightweight acoustic fabric in the world as well. And we're in other forms of filtration. We're doing anti-allergy bedding. working in areas such as clothing and high-tech materials such as that. So our business is effectively making rolls from materials that can come from a synthetic source, but our business focus is increasingly looking towards the natural and waste value streams and creating high-value products from waste materials. And so that's the point of this presentation, is to show you how we're using electrospinning, our process, to create high-value materials from what would typically be a waste. So we've designed and built our own machines out in Henderson. We now have the largest electrospinning machine in the world devoted to collagen production. Like Avatana, we've been slowly getting recognised around the world for our scientific nous, if you like, our abilities to create great new products using weird and wonderful materials. That was the video. And so that's just a screenshot effectively of what's behind the active layer product. So this has been an interesting journey for us. We discovered collagen, that we could create a fibre from this waste collagen effectively, or waste hoki skins, way back in 2015, I think it was. And we saw a fibre that dissolved instantly in the presence of water. And we thought, well, our background was in air filtration, and we thought, well, this is not a very good filter, if it dissolves instantly in the presence of moisture. But collagen being collagen and being such a huge market out there, we thought, well, maybe there's some way of taking this sustainable New Zealand collagen and turning this into a cosmetic product, delivering active ingredients into the skin. So that's effectively what we do. We take the collagen, we mix it with bioactive ingredients, anything from hyaluronic acid to a drug compound or vitamin C or honey, and we use collagen to deliver the active ingredients into the skin. Most cosmetic ingredients, or most cosmetics, no matter which one you buy, is probably 90% chemical. So even if it is a natural product, it is still being carried by emulsifiers, parabens, sodium lauryl sulfates, all sorts of things that make up the bulk of the cream or the serum or the goop, if you like, in a face mask. So we've removed all those unnecessary ingredients, and we're just using naturally sourced materials that are delivered into the skin. So it's really only the active, only the goodness, which is going into your skin, nothing else. But that's not all we do. Well, that's active layer, sorry, and we've got the fastest penetration rate in the known literature. So effectively, the active ingredients sink deep into the skin, 1.5 millimetres into the skin within the first minute. So it is replacing the kind of face masks which typically take 20 minutes, quite a long time, or the creams and the ointments, which there's a lot of debate about how many of those active ingredients are going into the skin or sitting on the surface. So that's active layer, and I do encourage you to check it out. You can buy it online. And the end of the story for us, I guess, well, the start of the story and the end of the story, if you like, was that going into the Asian markets for a cosmetic product, we're talking to companies who make 50 million face masks per month. And in China right now, 88% of Chinese ladies wore a face mask last week. I mean, this is a massive, massive volume game. And we've got a really big opportunity to move tons of waste, or what would typically be waste hoki skins, and turn them into a high-value product that's in a really, really big booming market. But we had to get the scale, and such as Avatana, we had to build arguably the biggest machine in the world in order to even meet a fraction of the demand for this. And furthermore, we had to take something that was very much a lab scale extraction process, and working with Sanford, take that up to the industrial scale. And there's still a long way to go there, but it's a really exciting field to be in. Some other products. Our first product that we actually made, when we only had one little needle making fibre. We also got a product in market, and we were creating filters for HRV systems. And we could create these ultra fine fibres that were capturing dust as they were coming out of the ventilation system. And our fibres were all naturally derived. They were antimicrobial using Manuka. And then we were putting them on a piece of plastic, and we kind of felt that was a bit stupid. All our fibres were, telling the great environmental story, but we were putting them on a piece of plastic. So we worked with a company called Potato Pack, now called EcoPack, and designed a biodegradable filter that we applied our fibres to. So now when people change their filter out of the HRV system, they can comfortably throw them in the bin. Air filtration is a huge market, but also it's a massive, massive waste stream. There's not a lot you can do with a dirty filter, so they tend to fill up the landfills. So we were trying to encourage at least the story of using biodegradable materials for end of life. This is a cool story. So Xantulayer, our product Xantulayer is typically, we've been using for for 2 years at least, virgin nylon. So nylon that had kind of effectively come straight out of the chemical plant to create a product that sits in between the plies of carbon fibre. So it's there to make carbon fibre products last longer. We can increase the lifespan of carbon fibre products by up to 4 times, and the impact damage and tolerance of bending and flexing carbon fibre products. But we discovered and started working with a company called Bureo in California, and they've got a stewardship program in South America where they actually encourage fishermen off the east and west coast of South America to bring their nets back in. And those nets are then collected and cleaned and repalletized, and we end up with this sort of black granules of nylon that has previously been,
Hold it up here.
Oh, there we go. Sorry, yeah. Previously been used or effectively discarded out to sea. So there was the whole problem of fishing waste, and there's a whole problem of the environmental pollution of nets being cast aside. So now we're encouraging people to bring them back, and we are then turning that into a nanofibre sheet, which is effectively like this, an incredibly lightweight, high-value material that it can be used in anything from fishing rods to Formula One, cars, all from recycled fishing net as its first start of the life, if you like. So this is an exciting field for us. We've only really just launched this. It's called EcoXantu, and anyone who's in the kind of sporting goods who want to continue that environmental story, it's a really important part, if you like, of the sporting good brands. EcoXantu is effectively a really good product to start using in order to increase the lifespan of your carbon fibre products. So that is another example of some materials we use. This one's a little bit more high tech. We've been working with Scion for quite some time. I don't know if you know about a polymer called lignin, but it is the second most abundant polymer on the planet. It pretty much makes 40% of the tree. And it is a big waste in the pulp and paper industry. So what they call black liquor. That is effectively something that comes out of the pulp and paper industry. Once they remove all the cellulose and make it into paper, you get this black goop at the end. That's primarily made out of lignin. And we can electrospin that lignin and turn that into a fabric. And the interesting thing about this is that that can then be carbonized into carbon fibre or carbon nanofibre in our case. So the carbon fibre industry is, a really big polluter. It starts with a polymer called polyactinyl nitrile. It uses huge amounts of energy, 2,000 degrees, to effectively carbonise this polymer, and the gas that comes out of it is effectively hydrogen cyanide. So it's a big polluter, and so we're using a plant-based resource to carbonise that at much, much lower temperatures and turn them into carbonised products which have the potential to get into the energy storage and effectively the energy industry, so replacing what would typically be chucked out as waste as well. So our process being electrospinning, it's very much a way of creating advanced textiles and really, really high value products out of what would typically be waste materials. We don't use big volume as Avatana does, but we're certainly creating really, really high value products out of these waste streams. And I think that's the key. I think that's where people need to, they need to embrace these types of innovations. There's always a good story associated with them, and so the brands that we talk to and we sell to, they like to be associated with that. And that's our journey really, is to show industry what's capable of natural resources.
And to show New Zealand what's capable too. I'm geeking out, I hope you are too. Okay, team of 12. You've got a lot of products going on.
Yep.
How do you do that?
Well, we're very good at what we do. So I guess, when we first had our machines, we were having production rates that would take us a week to make what we can now do in a day. So there's a lot of production efficiencies that we've had over the years. We've got a great team of scientists, and we also, we've done a lot of the R&D and the development, and so we do rely on people like distributors and other salespeople out there to move our products. So we're just sticking to what we're good at, making the nanofibre, and 12's good at the moment, but of course I think we'll be growing quite a lot in the
So you
coming
don't
years.
actually have to do any of the marketing, you just have to set up like wholesale arrangements sort of, and then people take your product and do stuff with it.
Yeah, effectively that's what we do. We make roll goods. I mean, active layers are a little different. I mean, because we're such an innovator in the market and so far ahead of the market, essentially we've had to create a brand that we've been responsible for selling. But in the coming months, we've got other brands taking our technology and putting it under their umbrella, and that's our preferred model.
Cool. Do you just go to work some days and just be like, there's waste over here, I'm going to create a fibre out of it?
Yeah, well look, to be honest, once you get onto this, I would say bandwagon, and you start to get pretty passionate about that. We're definitely more passionate about the ones that have a good sustainability story, that we are creating high value out of that. So it is a motivator. If you've got nylon that is just coming out of a chemical plant, but you can actually use something that's been pulled out of the sea, you definitely want to see that one go out the door a lot more.
It definitely, this is your biggest issue for both of you is scale, right? Like you can't go fast enough. And I think it's super cool. So South Auckland and West Auckland, you've got two of probably some of the most innovative waste reduction companies in the world. That's pretty awesome. Okay, we've got about 7 minutes because I just wanted to let you roll. I wanted to talk to you a little bit about collagen, and we had this discussion before in the green room, which is there's a lot of collagen on the market at the moment, especially in New Zealand. And we had a little bit of a chat around how it was sourced. And so for people that might not know at home, where's the collagen coming from and how's that different to what you guys have?
Oh, good question. So most of the collagen on the market comes from either horse, cow, or pig, and it's usually a byproduct of the meat industry, and effectively it's been on the market for a long time. There's sometimes quite a lot of very low protein content, so it's mixed in with a whole lot of stuff that nobody really knows about. But I think the biggest challenge is that half the world effectively, or the big cosmetics users, are either Hindu or Muslim. So they could be using something that's against their religious beliefs. So there's no halal collagen out there for what we know. So marine collagen is making a big push, and if you can get marine collagen from the cleanest oceans in the world that is sustainably fished, which I should have mentioned before, that the Hoki fishery is one of the most sustainable fisheries in the world, that kind of story is hopefully going to steamroll a little bit, and that we would actually be able to create quite a big collagen industry from New Zealand.
Yeah, and it's sourced from New Zealand,
It's
which
sourced
is
from New Zealand.
the main part, right?
Yeah, and I think in the marine sector that's the big opportunity.
Yeah, how exciting. Okay, James, let's go to you. What has been done in other countries to mitigate this issue that New Zealand could look to?
So waste generally is probably too big a problem for me to answer, so I'll stick to what I know. So yeah, in industrial waste globally, there's been a whole range of measures taken over the years. So Europe really got into it in the 80s and actually started to regulate a lot more, and they had a combination of subsidies and some punishment for companies that didn't toe the line. It worked really well, and they were able to really improve environmental performance across a range of industries. China's going through almost exactly the same thing now. So they've got some fairly tight regulation being imposed by government, but also providing mechanisms for companies to be able to afford to pay for technologies to upgrade what they do. I think here in New Zealand we don't have a lot of heavy industry, and because of our RMA, I think our performance is probably on a par or better than a lot of other countries, but there's still always more that can be done. And I think you really need a partnership approach between industry and government to make sure that if you do tighten up regulation and you do move towards ultimately the goal that everyone wants to get to is zero waste, it's done in a way that's not going to cause a lot of stress and strain, especially because some of these companies are really big employers, and for the towns where they're located near, it's a big deal. If you think of, for instance, the Bluff Aluminium Smelter, New Zealand Steel, those kind of companies. So it definitely needs to be something where there's some give and take, but ultimately with the vision of going to completely eliminating waste in the long term.
And it's definitely, I guess, doable if you can find a solution of how you use the waste, like kind of ecosystem, to create new things so you don't end up with that waste. For you two, I want to know, I spent a bit of time in Singapore, and as we know, Singapore is tiny, but they were on a bit of a mission to do high value manufacturing, and I know they do a lot of airline stuff up there. And so would you consider yourself kind of high value manufacturers, and do we need more of this in New Zealand, where we're not just exporting our raw materials but actually turning them into something, even if it's as small as like this little fibre sheet down here, and then sending that out to the world?
Yeah, well, I do consider us high-tech manufacturing, and the, even though they kind of look innocuous little fabrics, they are quite advanced textiles. And you find that the big established industries, such as Asia, the people who are doing in our field textiles, they're not innovating. So you typically need to start from the ground up. The ideas come from New Zealand and countries like us. But we're not going to make money if we just keep exporting ideas. I think there is definitely a place for us to get to pilot scale, get to the industrial scale, and if it needs to be expanded and put overseas, that's not a bad thing. I think we just need to show that it can be done. And globalisation, if you like, of these ideas, there's heaps of opportunities to sell that know-how going forward, in my mind.
From my perspective, what we do at the moment, I'd say that our products range from low commodity value for the stuff that goes into cement to what you'd kind of put on the border of specialty chemicals. So about $3,000 US a tonne is what pigment's worth. That's still nowhere near as high value as the sort of specialty products that Revolution Fibres and others make, but we certainly are exploring opportunities to push that value envelope further. And for instance, with our aluminium sulfate product, we did some really great work with Victoria University and the McDermott Institute last year to turn that from basically a commodity water treatment chemical into very high purity, high surface area aluminas. And so those are used for things like environmental catalysts. So if you think about a catalytic converter in a car, or something that's used to convert one chemical into another in processing, then it's about 10 times uplift in value for that product. So it's definitely something that's on the horizon for us, but right now I think the big focus is on getting our technology out there here and elsewhere, and starting to chew through some of those waste mountains.
Awesome. Michael, looking at what you have created, what are the opportunities for development in this area and that can be applied to other sectors?
Yeah, so I think there's definitely a lot that you can do with this sort of technology. If you look at like the fashion industry or electronics or things like that, there is still a lot of stuff that sort of gets sent to waste because it just hasn't sold in time. So, you could sort of take it in that direction. I think the thing that's really unique about food is like it has a really short shelf life. So if you miss that opportunity, it's sort of gone. And then I think for me, obviously sort of moving up that production chain and seeing where we can make other changes to sort of the whole food sector where there's obviously some issues going on. So yeah.
You can't take our waste food and turn it into fibres that we can wear as clothes. Well,
I guess all these hoki are pulled out of the sea to eat, and the skin is definitely a waste. Or it's got very low value as it is right now. And in fact, if you take the collagen out, you've still got an opportunity to put the rest of the skin into other areas. So it's a step in the right direction. We've definitely got a lot of ideas in the food space as well.
Yeah. Sorry for being cheeky. I was thinking about a tomato dress for some reason. I don't know why my brain went there. Okay, we could talk about this forever. We've got about 2 minutes left. So give me your vision for where you want your sector to be in 2050, so in 30 odd years.
Yeah, so I mean, as I sort of outlined at the beginning of my presentation, like our distribution and production of food is sort of all over the place. So that really needs to be sort of ironed out and equalised so that everyone has access to food. And you know, I think that people just need to really change our habits. We have this sort of really disposable mentality, and we just have to change our consumption habits because the planet just doesn't have to 2050 to wait for us to do that. So yeah, just sort of wanting things on demand all the time. Just, you know, we need to kind of curb that in and think of everyone as well as the planet around that. So yeah, just making sure that everyone's got access to food and we're not wasting it.
For me, my dream outcome is really that heavy industry is just done that way. You know, looking forward into the future, that becomes very normalised, that what we're doing today sounds kind of borderline science fiction, but actually that becomes just how it's done, and it becomes widely propagated, and it's not just in a few industries, it's actually just how industry generally works.
And if I think about ours from the textiles perspective, you know, I think we've been moving away from the synthetic space and more embracing the recycled materials that maybe have come from the plant, using materials a lot better, and yeah, thinking outside the square. And I think if that continues, then, you know, textiles and clothing and the like, they'll be a much more sustainable choice.
It doesn't seem like any of you have a problem thinking outside of the box, so well done. Good luck for your app launch. That's all we have time for today. Thank you so much for joining us. Thanks for tuning in to Techweek TV, and we'll see you back here in a moment for another session. Thanks, bye.